Okay, we start. Um, Today we continue on chapter 13, normal distribution. This is the center of our statistics. It's the center, which means it's a fundamental. This is the fundamental of statistics. Fundamental of statistics. Which more is makes sense. We are kind of in the middle of the semester. So we are learning the fundamental of statistics. Um, it's right. The timing is right. And last class we did the coin, the throw the coin. Last class we did the. We are not doing it today because it takes too much time. But I just continue. Okay, we did last. Suppose this is a coin. Okay, suppose this is a coin. And to make the number better, last time we did is we had the 28 students, 28 people, right? And today, to make it easy for my teaching, let's say we had 100 students. Okay, let's say we had 100 students. And everybody threw a coin, and now I just make some fake number. Okay, we did 20 times, right? And 1, 2, 3, and I make some fake number. Let's say this time had 35 is a head. Okay, now this is 60 head. Okay, totally is one, and is 48, and we don't need the TV right now. And let's say 56 is head. And 62, 70. I'm writing some 35. 48. And this number of is a fake. Okay, so and we did 11, 12, and we finished 20 times, right? Let's say we had 100 students. So then I did is let's say 35 has some number of times. let's say um, three, three times, okay, and um, 36 and some uh, uh, eventually the the 100 students. So the 50, I should make it red. 50 or 48 or 52 uh, should happen relatively more frequent. Uh, Makes sense? Makes sense? This 48, so 48, I made this number because in theory, you know, is a 50% chance. We know this is a fair coin. We know this is a fair coin. In theory, if I just use this, throw it 50 times, 100 times, in theory, I should have a 50 times head. I should have a 50 times head. But if I really do it, some scientist, not just, he really did, not just 100 times, he did by tens thousand times in the book, just to study, to check. Um, if I do it 100 times, I should have 50 times ahead in theory. So this, because it's up and down, because there's a random chance, or call it a random error. Call it random error. However, the 50 should be more frequent, okay? Should be more frequent. And so this is a bell curve. This is a bell curve. And it is also called the normal curve. It's called the bell curve. It's also called normal curve. This happens when anything is a random. When anything is a random, you will get this bell curve. It's a symmetric. One thing is a symmetric. There's an equal chance you will hit higher or equal chance hit the lower. You have the equal chance is more than 50, and you have other chance is less than 50. you have other chance is less than 50. If we have 100 people and we do everybody do this, we will get uh, this kind of numbers. We will get this kind of numbers. It's a random chance. The reason I made it 100 is so for the first experiment, we get 35 students with a head, which means in this experiment, what's the probability, according to the first experiment, what's the probability of getting head? What is the probability? What is the probability? It's 35 divided by 100, okay? It's 35%. In this experiment, we get 60. What's the probability? 60%. This is why I make it 100, so it's easier to teach. In reality, we had 28, and the division is tedious, okay? So it's 48% and 56%, and so on so. So the label here, instead of a label say 50 times, usually we label it probability. So here is the probability is a 50%. Okay? Here is a probability is a 48%. Okay? 52%. And so the 50% probability is most likely. Is the most likely. Is a random. This is the random. This is the random situation. It's a very, very important. For example, if the story behind the data, telling if you see this curve, then you need to realize this is a random situation. This is a random situation. I always want to teach my students in statistics class is when you're looking at the data, you should understand the story. You should understand the story behind the data. Not just look at the data. When you look at it, you need to realize the story behind the data. For example, here is a question for you guys. If we did this experiment, 100 people, okay, throw the coin, and here is the data. Here is the data. data. Uh, I have imagine 100 people, and um, let's say this is a 50% chance, okay? 50%, I make 150, okay? I need to this because I'm keep saying the 50%, and you do not see any 50. Let's say this is a 50% chance, okay? And so and so. Please keep quiet, okay? Anyway, look at me, okay? My nice shirt, okay? And this is the data. So 50%, okay? This kind happened relatively more frequent. And here, let's say this is a 70%. Here, 70%. Okay. So let's say, oh, here we go. I make it. Here is 70%. Okay. 70% also has a little peak. Also has a little peak. 50%. No. When you see this, what's the story behind this number? What's the story behind it? What's the story? Oops, I didn't draw it well. What's the story behind this? What's the story behind this? 100 people are passed out 100 coin to 100 people. And we did this experiment. Some 35%, some 60%, some is a 50% chance, some is a 70% chance. This is how many times? This is how many times, okay? And we got this. What's the story? What's the story? The story is the coin. There are two kinds of coin I developed. One kind of coin is a fair coin. Another kind of coin is on average is a 70% chance. On average is a 70% chance. So the 100 people, the coins are not identical. There are two kinds of coins are passed out. Okay, so when you see the data, you should have a story. You should have a story behind it. Okay. Now, I just borrow. I just to save the time. I just borrow it. Let's say um, let's say at the end. Let's say at the end of the final exam, this is the score, and here is 50, the score 50, and how many students, okay? And here is, it does not have to be 50, 51, 52. You can group them. For example, this one could be is uh, between 55 and like 51, 52, 53, 54, 55. This ball, okay, this ball is 51 to 55. And this ball is 56 to 60. This is the exam score. Exam score, okay? The middle one, okay, could be say, uh, oh, could be anyway. The middle one could be is 50 or 50 to, let's say middle one is the exact number doesn't matter, but 51 to 55. Here, this here is a 56 to 60. Okay, here is 46 to 50. The score, okay, the score. And here is how many students. Here is how many students. If at the end of the semester, I grouped. Now is your exam score. These are exam score. If I see these, what's the story behind the data? What's the story? What's the story behind the data? Random. If I see this, you guys score distribution. This is called distribution. Distribution. Oh, here we go. Distribution. If I see you guys score distribution like this, then it tells me that none of you know any, do not have any understanding of the exams. You guys did is close your eyes and so some lucky students will have the higher, like here maybe let's say 71 to 75, and equally some unlucky students like have 30 to 35. It's a random. Then I will be very scared. Okay. So the data, there's a story behind the data. There's a story behind the data. We cannot tell all the stories, but this is the starting point, the normal distribution. This is the fundamental. Now, if I tell you these are the cancer patients surviving period. Let's say this is the how long the cancer patient survived. This, let's say the unit is a month, 51 months to 55 months, 56 months to 60 months. Now is the months. Let's say we tracked 100. We tracked 100 cancer patients. And these many patients, after diagnosed cancer, they live this much, 51 to 55 months, then they passed away. Some are even sooner. Some are even sooner, like 30 months, then they passed away. Some live longer, maybe 70 months passed away, but their number is small. And here, they died, those passed away sooner, their number is small. Those who live longer, their number is also small. And here, they live this much longer. Most live in these months. So what's the story? If you went to the hospital, you studied the 100 cancer patients, and you get these numbers. What's the story? What's the story? Yes. So this tells you that how long they live is something randomly happening. It's like somebody is tossing a coin inside the patient's body. Just like you guys tossing the coin. Something randomly, you are up, die, and you live longer. Just like when you tossing the coin, that some small chance, you get like 80%, you get 80% head, small number, and the small number this mostly you got 50%. So this says there's a kind of a coin inside the patient's body. There's a random thing going on. This is used by this biologist knows that something, one switch is a switch is yes or no, yes or no. It's a kind of like this yes or no, yes or no. Some lucky ones get a higher, but mostly. So it is probably a protein. So for biologists, if this is, they will say there's a single protein inside the human body. In this randomly, yes or no, yes or no. This is why some get, that's a random situation. So by looking at the um, data, we can get. I'm not saying by looking at all the data we can no, but in this situation, we can get the story behind the data. Are you following me? Are you following me? Um, I can give you another example. Let's say we are studying this time is not exam school. We are studying the salary. We are studying the salary. The salary. We are studying the salary, and let's say Kunming, all the people's salary, and the unit maybe say this is a K, I know. Maybe this is a 60,000, okay, 1 year. This is a 56,000, and there are this many people, and this is a 70,000. Let's say this is a 70K, 70,000, and this many people, and here is 30,000, and we have this many people. If we study the people's salary, and after this story, then we finish. Okay, we are waiting for our classroom. I know. Listen to this. It's very important. Okay, if we study people's salary and in this range, then what's the story behind this? What's the story behind this? Right. This will be very scary. This will be very scary, which means people in Kunming, the rich people or poor people, is random. You randomly be rich or you randomly be poor, and mostly is in the middle class. It's random. This would be very scary. It's like some people is throwing the money from the helicopter. Throw the money from the helicopter, and people in Kunming, you just grab the cash. In that situation, then people's wealth is randomly distributed. Okay, we stop here. We need to find a different classroom.